Hey, what's happening, guys? I got a request from a viewer to show exactly how you can go about making PC boards for yourself with a CAD/CAM program, or yeah, I mean that's the only way I really do it. And he wanted to know about the layers and just the basic makeup that goes into making a board. So we're going to cover that, and then we're going to talk about the design software I use, EasyEda, and how you can make it work. So first of all, if we take a look at the board edge on, yeah, I know it's going to be hard to see there, but there are different layers. Let's zoom out here. Now let's start from the middle, where you have what's called your substrate. That's the fiberglass material the board is made from. In most cases, it's called FR4. They also make some out of epoxy paper and phenolic, but that's more of an old school thing. These days, you're going to find mostly FR4 boards. Next, on top of the FR4, you are going to find a very thin copper layer. And that's your copper layer. And you notice, in this, which we're going to be a double-sided board, has on each side of it, okay? So this is our copper layer. And copper is specified in ounces per square foot. I didn't do that right. It should be foot squared, but you get the idea. And generally, 1 ounce per square foot is used. You can also get 2 or 3, but generally we stick with 1 ounce per square foot. And then on top of the copper, we get, this is purple and blue, it's probably not even going to look different. You get what's called the solder mask. The solder mask is what keeps the tracks, and we'll talk about the tracks pretty soon, from getting shorted to one another or anything else. Think of it as just an insulation layer. And then finally, on top of that, we have a final layer, and that layer is the silkscreen. And that is where anything that you have printed on the board works. Whether it be component pin designations or instructions or graphics or whatever, it's generally only available in one color, and it's usually quite low resolution as well. So now that we know the layers of the PCB, we can talk about what happens on them. Starting with the substrate, nothing happens. That's just the beef, the body of the board. On the copper is where you'll have your traces, your pads, your annular rings, your fingers, whatever. And then that gets eaten away, leaving the individual traces, the rings, and all that. And if you take a look here at this board, the reason I'm using this one is you can see the traces pretty well. Come on, zoom in. There we go. So on top of the substrate, on top of the fiberglass, is that thin copper layer. And then what they've done is they've eaten away everything except for where the traces are and where these plated through holes are, and those are called the annular rings. But when you're talking about the holes themselves, we call them drill hits. So you have the drill hits, and then around that you have the annular ring, which is what you solder to. So all the rest of the copper gets eaten away, unless you specify what's called a pour, a copper pour, which you want to do for most boards that are going to do anything somewhat high frequency. And you generally do it on the back side of the board, and that's where you want to have all your grounds in one plane. But we don't have to talk about that. That's more of an advanced thing. We're sticking with the basics today. So now that you have kind of a physical description of the board, let's go to the computer and we'll draw up a real quick circuit and we'll talk about how you can put it together and make a PCB. Okay, so now we're at the computer and we're looking at EasyEda, which is a free online, or you can download it, piece of design software. This is the schematic capture part where you're going to draw your schematic. And we're looking over here at the EE library, and this contains basically everything, well, the basic parts and components of what you're going to need. If you see something that's close to what you want, but not quite what you want, if you click on this down arrow key here, you can change them. Like for instance, this resistor is an 0603, which is going to give you a surface mount footprint. Well, I don't do surface mount. I do through hole. So we'll go with the axial 0.3 resistor. And now, when we click on it here, we can bring it over here and drop it. So up here, we have VCC and ground. You're going to want to put them in every circuit that you design, because when you do your electrical rules check or your ERC, it needs to know those 2 points to start out with. So start out with them on every single drawing that you do. Now, we can come down here, we see we have resistors, capacitors. Again, this is an 0603. We don't want 0603, we want radial. We'll just grab one of them. We have inductors. We have batteries. See, there's a CR2032 battery. We have connectors. This is your basic barrel jack connector. We have header pins, male and female. And what you want is this size right here. If you're working on breadboard size stuff, that's the 2.54 millimeter. Now you see here is a 3-pin female header. Well, what if you want a 5-pin? Well, you just click on it, grab yourself a 5-pin. Okay? As we move down, we have more connectors. We have switches. Those are all SMD. There's a 6x6. This is your standard switch that you use on a breadboard. We have LEDs. Again, you want to make sure you're using the right size. If not, well, it's not going to work out well for you. Again, there are diodes. 1N4007 is kind of a standard diode. We have transistors. We have MOSFETs, voltage regulators. So what if you can't find what you're looking for here? Well, in that case, you can come over here to the library and kind of just type it in, what you're looking for. Say you want a 4017 chip. So you just type in CD 4017. Let it search for it and find it. And then you can come down here and just click on them. And then look over here to make sure the footprint is what you want. See, now that's a surface mount one. You don't want that. See, this is the SOP 16. You want the DIP 16. So you can look down here. You can just find one that fits your needs, and you can grab whatever you want there. Click place, and it will allow you to place it in there, just like that. All right. Now, let's talk about placing components. We'll start with a simple resistor. Bring it out here, and we'll drop it. Now it stays here, so you can do another one. Just hit the escape key and make it go away. Now what you want to do is you want to click on it. And you see it has a prefix. Every component needs to have its own individual prefix. They can't share a prefix. But the name we can change. So say you don't want a 1K resistor, say you want a 10K. We just come over here to the component attributes, and change it from 1K to 10K. The program doesn't care. Okay, that's just for you. Now you can also click on it and hit the R key on your keyboard to rotate it into whatever position you want. You can also right click on it to cut, copy, paste it. You can edit the symbol. See prefix R1, R2 pins, whatever you want to do there. So you have a lot of flexibility in what you put there. So let's make a relatively simple circuit. Push a button and it lights up 2 LEDs, okay? That's about as simple as we can get. So let's think. We have our VCC, which is our plus, we'll call it the plus, your positive voltage, and we have ground, which is our 0 voltage, or our reference. But we need a way to get the actual power into the board. So we can do a CR2032. Or we could bring in a header pin. Or we can bring in a barrel jack. Let's do a barrel jack. So we'll bring it in, and it really doesn't matter where you put it, but think logically. Think going from the left is your input, in the middle is your logic, and on the right is your outputs. Just think of it that way so everything flows. So we'll just stick this kind of right here in the middle. And then we're going to come over here where it says name, and we're going to say this is 5 volts DC, just so we know. Now, let's come in here and zoom in. And to zoom in, I'm just using the mouse wheel. Roll it up, we zoom in. Roll it down, it goes away from you. Now, if you click the mouse wheel and hold it, you can move your sheet around, okay? So, pin 1 in this particular case is the positive voltage in. So we're coming over here to get to our wiring tools. And this one right here, the wire, see how it makes a dot? That means it's connected. So we'll click, and we'll come out until we can see our VCC. We'll just come up like this. And see how it's made another dot? That's a connection. If you don't do that correctly, it's not going to pass your electrical rules check. Now we're going to do the same thing for our ground connection. And you don't have to draw your lines like this, but you do want to keep them somewhat logical. All right, now, with this particular connector, you need to connect these two together, or you're not going to get your ground. It's a switch kind of thing. All right, so now we have power going to VCC and to our ground. So it just so it knows what's going on. All right. Next, let's bring in our switch. And we will put it here. I'm going to rotate it. Now you notice it says key 1 is our prefix, that's fine, and then up here, I'm just going to call it power switch. I'm going to rotate it again, just so we're done. Pin 1 there is power, and keep it as logical as we possibly can. So you got 4 different connections here. You only need 2, and you want them to be on opposite sides. So what we're going to do here is we're going to bring pin 1 up to VCC. And and pin 4 down to ground. No, we're not. Okay, I made a mistake there. We don't want to do that. So all we need to do is come here and click on the wire we don't want. Get out of there. And then hit delete, and it goes away. All right, what we actually want to do is put this in the VCC path. So I'm going to get rid of that wire as well. I'm just going to bring this up here like this. And now we'll go this way. Yeah. The way I did it first would have been shorten everything out. And it wouldn't have worked very well. Okay, so now when we press the button, we bring power in and to our positive rail. Now these two unconnected pins here, you need to mark them with this little X here, which is the not connect. If you don't do that, it won't pass the electrical check. Okay? There we go. So now let's bring in our LEDs. And I'm going to rotate them, anode up, cathode down. I'm just going to put them right about here in the middle. 1 and 2. Then again, I'm going to click on them. We don't need all this here for the name. We're just going to call it lead 1 and lead 2. All right. Now we need a resistor, so we come up here and get our resistor. We're using those axial resistors. We'll put one coming off of each cathode here. 5 volts. We could go as low as 220 ohms. We can go up to K, anywhere in there. Let's go 330R for both of them. And now you can see that those aren't quite lined up. Now they are. Okay. So now we need to connect everything up. We'll just grab our wiring tool and we'll connect the anode of the LED to our positive rail. We'll connect the cathode of the LED to the resistor. Resistors are unpolarized, doesn't matter which way you connect them. And we'll connect the opposite side of the resistor to ground. Now I drew this all spread out here, just basically for the instructional end of it, but you can draw it however you want. So now we have everything drawn up quite nicely. You can come in here if you want and use this text tool and put in any notes about the circuit that you want to have on your drawing. It's kind of like that. No problem. Then you want to save it. You want to save often so that bad things don't happen. Alright, so now looking through here, advance. We will do convert to PCB, and there were no problems with our electrical rules check. Very good. Okay. Now we're ready to go into the PCB end of things. And this is where we need to discuss all the layers and all of that kind of stuff and make sure that we're putting things into the proper layers. So the first thing I want you to know is that you can come back up here and click, well, once we do this, onto your schematic so you can go back and reference it. Now it's making this board 37.338 by 24 millimeters. That's fine, but I'm just going to make it 40 by 25, just to keep it easy. And I'm also going to make it a round rectangular board, so we don't have any sharp corners. Click OK. And you can see there's our board. I'm just going to drag all these down here so we have everything close to where we need them. Alright, so here you have your layers and objects. And I'm going to lock that there so it doesn't go away. Now you have these eyeballs. The eyeballs mean that it's showing you them. If you don't want to see a particular layer, you can take it out. For instance, let's just start with the board outline. So that is the physical outline of our board. You can click on it as long as you're editing with that little pencil mark I just clicked there. You can click on it and you can move it around. You can adjust the different sizes. You can change the radii, whatever you want. Just click on it, move a piece, but make sure you get it all back together. Okay? Next, we're going to see our top layer. Now let's bring all our layers back in. So we're going to go to the top layer to place our components. If you have components you want to place on the bottom layer, you can do that too, but I'm going to try and get them all placed onto the top layer. So I'm going to click top layer in this box here, the color box, and that means we're editing on the top layer. So everything we do is going to appear in the top layer. Now the next thing I want to do is I'm just going to select all these components at one time, and I'm going to come over here and say display prefix, no. Display name, yes. I don't care what the prefixes are. You probably don't either, but the program does. We just want the names. So now we need to figure out some sort of logical placement to put these. Now if you see these blue lines, these are called rat lines, also called air wires. We want them to be as straight as possible with as few of them as possible crossing each other, so that when we go to route the board, meaning draw the traces out, it's just easier if there aren't any crossing. So let's start by bringing in our power connector. And I'm going to put it right here. I don't care if the end of the power connector hangs over the board a little bit, but in general, you don't want your components hanging off the end of the board. This is one where it doesn't matter. Alright, then we've got our power switch. And I'm going to put it down here, but now let's see if I do this. See how they're kind of tangled up? What I can do is just rotate that a couple times. And now our air wires aren't so crossed. Alright. Then we're going to put our LEDs where we want them. And we can move this stuff later. We're just getting a general placement here. And then our resistors. Alright, so everything is placed on the top layer, and I'm just going to zoom in here so that we have a better look at things. Alright. Now, let's go to the top silk layer, and we can individually move just the label. See how I did that? I just clicked on it. I'm going to rotate that, and I'm going to put it over here like this. Power switch I'm going to bring up here like this. Then the resistors I'm going to put underneath of them so we know what their values are. And then our LEDs I'm going to put over here, kind of centered. Just giving us a nice, thoughtful look at that. So far, so good. Now the next thing I want to do is I'm just going to take that resistor and put it on the junction of those two lines there. And I'm going to do the same with that resistor. So they're nice and even. Then I'm going to take this LED and make sure it's fitting nicely between those lines. Same as that. Good. So everything's relatively even and looking nice there. All right, so we have our components placed, and we placed them all on our top layer. Everything is good. Now we get to the point where we get to route the board. All right, let's route our board. And in full disclosure, I generally use the auto router. I don't like routing. Some people like it. Hey, that's cool. So we're going to come over here and we're going to grab the track tool. And we have to make all of the blue lines disappear into our routes. Now, routing is basically very simple, but when you really get down to it, it's incredibly complex, and it requires a little bit of pre-planning. It's kind of like playing chess. But the basic idea is you click one spot, you drag it to the next spot, you click again. That's routed. Pretty simple. And we do the same thing here. Boom. Here. Boom. Here. Boom. Here. Boom. Now things tend to get a little bit more interesting. Let me move this out of the way here. We're going to come in here and zoom in a little bit. So now we need to connect this to this and over to here. So far, not too hard. I'm going to click here and I'm going to come over. Like that. Let me get rid of that route. I just hit delete, that's all, nothing special. When I click, what happens is it just kind of anchors that point. Okay, so there's another route. Now this one, we have to come from here over to here. So we can't go through, well, maybe we could, but I'm going to go around. So we're going to come out this way, down here, down here. Okay. So now, we have to route our switch. But we can't cross those lines. We can. There's a way to do it, and we're going to do it like this. We're going to make a via, or a hole in the board, to bring our route from one side to the other. So we're going to come out of here. Then we're going to come down, and I'm going to press the B key, which brings us to the bottom of the board. And we'll keep coming down to here on the bottom. I'm going to let go of it. And we've routed that on the bottom. And I think we are all routed. Let's do a DRC check, which checks our rules, make sure we haven't done anything bad, no errors, everything looks good. I'm going to save it. And then we can go view, 3D view, and it'll give us a nice look at what our circuit is going to look like. Now here, grab the pencil, you can see our via. We came from this point on the switch down like this, but there's another trace coming here which we couldn't cross. So we switch to the other side of the board. We'll come around here. And you can see that's where we came through. So we've passed our design check. We've looked at the board. It looks pretty good. The next thing that you want to do is you want to put your labels on the board. So we're going to come over to our PCB tools, make sure we're on the top silk layer or the bottom silk layer if that's where you want to put it. Get your text tool, decide where you want to put your text, click and that places it there. Then we click on it, move this out of the way, and our text. Learn electronics, LED circuit. Click, and there we have it. But you see how it's kind of interfering with that? What we can do here is we can come down here and change our height. That's 2.032 millimeters, or we can change our font family. I'm just going to do that. Go to Demi Light. And now we have a much smaller one. You always want to put a version number on there too. And we will say that this one is V1 and today is 9/17/20. There we go. Now, if you have a logo that you want to place on there, like I placed my little bear logo, it needs to be a bitmap. I'm not going to tell you how to create a bitmap. You got to figure that one out yourself. It needs to be 2-color. Then you just click on this little image, select image file. In my case, it lives in the pictures folder. It's called Happy Bear. There it is. Image size, I'm going to go about 8 millimeters by 12. Insert it in there. Now, you see that's still too big to really fit there. But I'm going to go ahead and click it. Then I'm going to come like this. You see we have 8 by 12 or 8.0, whatever it is. I'm going to change that to 6. Hit tab. Maybe 9. Back tab. That's much better. Now it fits. Save it. And then let's view it once again just to make sure everything looks as we expect it to. Which it does. Good. Now, if you want something on the back side of the board, you come here to bottom silk layer, and you can print whatever you want there as well. But take a look at this. See how it does it backwards? It's not really backwards, and I'll show you that in a second. See, it looks backwards here, but when we do our 3D view, you'll see that it prints it the right way. It's just showing you it backwards so that you know it's on the other side of the board. And once you're completely happy, save your file. The next thing we need to do is we need to export our Gerbers, which are the design files we have to send to the PCB board house. So in this program, we go File, Generate PCB Fabrication File Gerber. Check our DRC? Sure. Check our DRC, make sure everything's good. It is, no errors. Now, if you want to order from this company, you can just click Order here. If you want to order from somewhere else, you can just click Generate Gerber. And you can see down here on my screen that it has created the Gerber file, which now lives in my download directory. And you can go ahead and send that to any board house you like. So that is a super basic introduction to designing PCB boards. I hope you guys like this. If you did, please give me a thumbs up. And please, if you're not a subscriber, please subscribe. We're at 94,000 subscribers. When we get to 100,000 subscribers, we're going to do some big giveaways. We've got so far an oscilloscope, a soldering station, the new Nano Every. I even got a smart wall we're going to be giving away. Lots of stuff. So subscribe, tell your friends. All right? That's it. I'm out. Peace.